Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video is the part 2 of the chapter Thermodynamics from class 11. So let's start the second part of the chapter. In this part we will come across with some new terms. So the first one is reversible and irreversible process. Now, the process, first we will come with the reversible process. So, suppose when a process occurring, once it will be a very fast, it start and suddenly it ends. And the other one is, it starts slowly, very slowly, it is going on and on and on, it is taking very long time. So, this time dependent thing, which is very slow process, it is called reversible process, and when the process is very fast, it is called irreversible process. Okay, now let's have an example. Suppose we have a container and we put a piston over here, and here some gas is there inside the container. Now we have a small weights on the piston. Correct? Now what is going on here? We remove the weights one by one. So once we remove a small weight, what will happen? The piston moves back and the gas will expand little, because a little weight is removed. Okay, so pressure is little less. Now then gas will expand little. Then after expanding, when the pressure inside and pressure outside will be equal, again the expansion stop and equilibrium achieve. Again, when it is stable, then again we will remove one more weight. Again, the external pressure is lesser than the internal pressure and piston will move upward again, and then what will happen? It will slightly move upward and then stop. Why it is stop? It will move only until the P external and P internal, yani pressure external and pressure internal, will be in equilibrium. This type of process in which small changes occur, that type of reactions process are called reversible process. In this type of process, at any time we will put a small weight back and we will make the process reversible at any instance of time. On the other hand, if we have the same container having the same piston and the same gas inside, now in the other, here we suddenly shift the piston from here to here. Suppose like this, we shifted the piston from here to here. Now what will happen? Suddenly we remove the piston, means suddenly we decrease the pressure. What will happen? Sudden expansion of the volume will happen. Gas will expand suddenly and volume will increase. This is all happens suddenly. So this is called irreversible. Because if suddenly we expand the gas, it is very difficult to come back at the original position, which is the initial position. It is difficult. But in the case of reversible, because we change a very little difference, so it is easy to go back in reverse. Suppose one more example I will give. We have to climb from ground floor to first floor with the help of steps. So these are steps. We are climbing the steps one by one. And in the same height we have a slope to climb. So this big changes in the steps, and in the slope we have a small changes going up. So at any instant, if somebody tells to come back, it is easy to come back from the slope than from the steps. Coming back from the steps is difficult than coming back from the slopes, because in the slopes we are increasing the height very slowly, and in case of steps, increase in height is sudden. One step, sudden second step, sudden third step. So in this slope we can say the reversible, and the steps what we use, that should be the case of irreversible. So this is the difference between reversible and irreversible. Now come up to some properties of this reversible process. It is very slow process. Very slow process. It always follow the reversible path. Follow the reversible path. It means at any time during the process we can reverse the process, because the point is, because the process is very slow, or we can say it takes infinite time. It takes infinite time to complete the process. So if it is taking infinite time to complete the process, it means it is a very slow process, and at any moment of time we are able to reverse the process. Now because it is taking infinite time, it means this type of process is totally imaginary process, because in practical this type of process we can't study normally, which will take infinite time. How could we study the changes? So this is a imaginary kind of process, and it is supposed that the system and the surrounding are always in equilibrium with each other, because the change is so slow that little change, then the system and surrounding make the equilibrium, then little change, then equilibrium, then little change. So the system and surrounding always supposed to be in the equilibrium, in contrast to the irreversible. Now one more point which I need to mention here is that the work done in the reversible process is maximum. Work done is maximum. Same, the reason is because it is a very slow process. So the work done, we will take the maximum of the work done over here. Now in contrast, when we are going through the irreversible process, now everything will be contrast. It will be a very fast process. Next point, follows the irreversible path. That means it is not possible to reverse the reaction. Follows the irreversible path. Next point which should be mentioned is it's a natural process. It means it's normal thing. It happens naturally. It is not an imaginary process. Next point, that equilibrium always exists only in the initial and the final state of the system. So we can write equilibrium exists only at the beginning and at the end of the process. So because it's a sudden process, in the starting the system is in equilibrium with the surrounding, then sudden change, and at the end of the process again the system and the surrounding are in equilibrium with each other. In between there is no equilibrium. Okay. Now one more point, that work done is not maximum. Work obtained is not maximum. Work obtained is not maximum because it is a very fast process. See. Now this is the reversible and irreversible process. Now come up to the next topic, isothermal process. Now isothermal, as iso means same, thermal means temperature. So the process which occurs at constant temperature is known as isothermal process, and in this case delta T, which is equal to T final minus T initial, it will be 0. Isothermal process, delta T will be 0, or we can say the temperature is constant. Isobaric process. Now bar is the unit of pressure. From there we can get the hint. Iso means same and pressure. So here the process which occurs at constant pressure is known as isobaric process, and here delta P will be 0. It means difference in pressure will be 0. Next comes isochoric process. Isochoric process means here delta V means difference in volume, or volume change is 0. The process which occurs at constant volume, and in this case always the value of delta V is 0. And what is delta V? Delta V is the difference between the initial and the final volume of the system. Now next come adiabatic process. Now this is something different. Adiabatic process is the process where delta Q is the heat, delta Q is 0. It means the process occurs at constant heat. That is called adiabatic process. It means delta Q will be 0 in the adiabatic process. Now you have to remember these points. If there is a question and they are telling in the adiabatic process, they will add this term. It means there you have to put delta Q is 0. So that's why these terms should be important to be remembered. Now come up to the next, cyclic process. Now what is this kind of process? Suppose we have a reactant A and it end up with the B, product B. Now if we reverse the reaction, it is coming from B directly from B to A. Correct? This is called reversible process. Now what is cyclic process? So suppose we have A, that changes to B. Now this changes to C and C changes to D, and D again changes to A. So it means what is going on here? We started with the initial state and end up with that same state. We are coming back to the same point but using different path. So using different path is called cyclic process. If using same path, it is called irreversible process. If the process taking a different path and reaches the initial state, then it is called cyclic process. Like suppose there is a river and there vapors formed from that river and clouds are formed just above the river, and suddenly the clouds will start raining and the water will fall down in the river. It means vapors go up and clouds give the water down. It means going and coming from the same path. This is called reversible process. Now suppose now just above the river clouds form. Now clouds go somewhere else, then they give the rain in some other place. From that rain water come to the river. So as the water started from the river and come back to river but from the different path. Now this is called cyclic process. So hope you guys understand this much. What is cyclic process? A process which comes back to the initial state by using different path, not the same path. This is called cyclic process. Now come up to the next term, extensive and intensive properties. So in the first part of the thermodynamics introduction, we studied about the properties like pressure, temperature, volume, etc. So many properties we studied there. The properties which are used to define the state of the system. Now these again can be divided into two types. One is extensive property, the other one is intensive property. Now what is extensive? The properties we can say which depends on the amount of the matter. The properties, here properties means the pressure, volume, temperature, these properties which depend on the amount of the matter is called as extensive properties. It means the properties which depend on the amount. If the amount is more, the property will be changed. Now, so amount is less, the property is same property, the value is different. If we increase the amount, the property value will be different. Then this type of property is called the extensive property. Now example of the extensive properties are, first thing is mass. Now examples of this is mass. If the amount is more, mass will be more. If the amount is less, mass will be less. We are talking about for the same sample. If one more example is volume. It depends on the amount of the matter. If we take a big amount of matter, the volume will be different. If we take the small amount, the volume will be different. It means the property changes with the amount of the matter. So it is called extensive property. Some other examples are number of moles. Number of moles. Same here. If a sample is taken in the small quantity, then the number of moles are different. If the sample is taken in the big quantity, number of moles are different. Sorry. Next come in this series is heat capacity. Next is energy. Energy, all the forms of energy like internal energy, U, then enthalpy, entropy, Gibbs free energy. All these depends on the amount of the matter. If the amount of the matter is changed, the value of these properties will definitely change. Now, next is intensive properties. So the definition is properties which does not depends on the amount of the matter. Those are called intensive properties. For example, now let's have an example of intensive property. These are pH. First thing is pH. So pH, we understand what is that? To measure the acidity or basicity of the sample, we study the pH. The scale is pH. So if we have a sample, that sample we took in two different containers. One container we took only 2-3 spoons of that sample, and in another container we took 10 ml, or I can say that 30 ml of the sample. So same sample in two different containers with two different mass. One is less, one is more. So now if we check the pH in both the containers, does the pH change? The answer is no. Because the sample is same, so pH will be same. Either it is in less amount or it will be more amount. Understand? So pH is a intensive property. It doesn't depend on the amount of the matter. In the same way, we can say density. Density. We knew that honey. So if honey, we have a bottle of honey. Now take 1 spoon of honey in one test tube, and from the same container take 5 spoons of honey in other test tube. Now we have 2 test tube, one having 1 teaspoon, one other having 5 teaspoon. So means same sample of honey in 2 different amount. Now check the density. Whether the density will be different? No. The density will be the same whether it is 1 spoon or it will be 10 spoon. No matter the amount, density will be same. So this is called intensive property. In the same way, some other are temperature. Very easy to understand. If we take 2 containers of water from a river, one is a small container, one is big container. Both the containers having the water from the same river, and check the initial temperature. Does the temperature change? No. Both the container having water having same temperature. It means temperature is a intensive property. Next comes in this series is pressure. One more example is viscosity, refractive index, and molarity, mole fraction, normality. These all the properties which doesn't depends on the amount of the matter. These are called intensive properties. So guys, with this I am going to finish off our second part of thermodynamics, but still we have a lot to study in this chapter. So stay tuned with me. Do like, share and subscribe the channel, and don't forget to press the bell icon. Till then, thank you.